Okay, so what we're going to do in today's video is just show you a run through of a test file using noise directivity with SV200A, Svantek's noise directivity instrument. I've got a test file here that my colleagues have sent me from Poland, basically simulating some traffic noise and some unwanted noise with a barking dog. And I'm going to show you how we can recalculate directivity and deselect some unwanted noise. First things first, you'll open up the file in SvanPC++ and it'll be a time history. We have a few extra options here like a map, which can become quite useful when we're talking about directivity. Basically, it's split into 32 sectors as a pie chart. We can just select them on now for the purpose of this demonstration. Once it's all ticked on, play back the audio that's located in the file. On the radar graph, it's going to show us where these dominant sources are barking from. For example, the barking dog. So as you can see, there's dominant source coming from there. Pause it, we move a little bit forward. You can see the dominant dog there. Now we also moved the speaker to a different location. And you can see that it's coming from a slightly different location next to this house. Now if we go a little bit further, we have traffic noise. So we can assume that without the dog barking, we just have background noise. So background levels based on statistics L90. So you can see cars driving past. Zoom a little bit further. You can see the truck driving through the main road there. What I'm going to do straight off the bat, I'm going to duplicate this map and I'm going to put it into a setting called noise sources. And I'm just going to change the range to 80. So basically what this shows us is every second logger step as a dot on this radar view, it's called. And as you can see, we have the street down the bottom here and we have two direct sources, unwanted noise coming from two different angles here. So what I want to do, our goal is to measure the street and deselect the dog's barking. So deselect just the map with the street. So if we go shift, and now you can see that these are deselecting on the radar view. So that should be enough. I might do one more for now. First things first, we want to use the time history calculator in SvanPC++. So if we open this up, one thing you will need is an environmental monitoring dongle. It's a payable single license dongle, so it's basically an advanced calculator for SvanPC++, block markers, block generators, and advanced calculations. So once you have one of these, you can put it into the USB port of your computer. It'll pop up in the software telling you that it's connected. So what we want to do first is recalculate the directivity for the dog's barking. So clear settings, go down to directivity LEQ. I'm just concerned about profile 1, channel 1A weighted at the moment. Go down to calculations, hold data, running values, and calculate the intervals in per second and press calculate. And what this is going to do, this is going to produce another line on our time history. And as you can see, it's very close to the main measurement that occurred. But if we zoom in here where the dog was barking, for example, you can see that the measurement was actually really close to the estimated LEQ of the dog. But if we move further down where the traffic noise was coming from, you can see that there's a larger gap there. So that, you know, the dog was barking and it was lifting the level of the LEQ. And that's the purpose of today's demonstration. So what we're going to do now is use some block markers to create the different aspects of our measurement. So the first one is we're going to open up the block marker generator, press next, and we're going to select our recalculated LEQ. And we're going to use any level above 55 dB. So that's going to pretty much bring everything that the dog is barking above. Once that's done, we're going to hit finish. And it's going to tell us a number of ranges that are found with above 55 dB. Press OK, right click, go into edit markers, use selected blocks, new marker. Let's call that dog. And let's change the color. And we'll do it green. Okay, and then what we want to do is select that block. So go into marker and block, select the dog block. Now we want to invert that whole selection, so everything else. We want to create a new marker. So let's go into edit markers, selected markers, new marker. We'll call that the street. And we'll change the color for that as well. Let's call it pink for now. Yeah. And press OK. So what we want to do now is reopen the time history calculator. We want to clear the settings once again, but instead of using directivity, we're going to go to the logger LEQ. We're going to select profile 1, channel 1, because that's what we're concerned about. We're going to go to parameters and we're going to select standard calculations. Then we're going to go into calculation periods. This time we're going to select dog and street as well. And then we're going to press calculate. So SvanPC++, we're going to change this into accumulated view. Basically what we have here is a 1.5 hour measurement. We have an LEQ for the whole measurement, which is 64 dB. We have the street measuring 60.4 dB, and we have the dog for 23 minutes measuring 70 dB. So we know that the dog has a higher LEQ, bringing up the measurement value. So that's not all that is finished with this measurement. So what we can do is we can assume that during the 22 minutes when the dog was barking, it was generating a high level of noise. There was no high levels coming from the street. So what we can do is we can use a background level. So for example, in this case, 48 dB, which is based on the L90 statistical levels. And what we're going to do is we're going to do one more calculation. So let's go back to the time history calculator, open it back up. And this time we're going to go to parameters, and this time we're going to use a reference time and level. So enter the duration of the measurement, 1 hour, 29 minutes, 10 seconds. And also our background noise level, L90 background level, 48 dB. Now we want to go to calculation periods and deselect whole data. We can leave the rest as is and press calculate. Okay, so now what we have is we have a level from the street, which is 59.2 dB. And based on our whole data, which is 1.5 hours, which is 64 dB, we have a 5 dB difference here. So there's a drop in 5 dB just by excluding unwanted noise from the dogs barking. So there's just one simple example on how to use directivity. Thanks.